Hello, welcome to the CCNA trading video brought to you by Eduonics. This is chapter 2, video 2, but it's really just a follow on from um, the last chapter where we were looking at the technology and media access controls around switch networks. And we talked about FTDI, CSMA CD with collision detection and collision avoidance. But now it's time to actually look at switches and look at them on like a more kind of physical plane and see how they really begin to interact with our network. So, how do you determine when the network contention on your router will switch is getting too much? Well, the chances are if it's getting too much, your users are going to be reporting slow traffic, they're going to be reporting slow download speeds for all the basic things like just browsing the internet. So if your switch utilization is more than 35% or your collision rate is more than 10%, it's time for an upgrade, or at least to add another switch in. The utilization load is the amount of total traffic as a percentage of the theoretical maximum for the network type. 10 megabits in Ethernet and 100 megabits in fast Ethernet. The collision rate is the number of packets with collisions per percentage of a total package. So the benefits of switching vary from network to network. Adding a switch for the first time has different implications than increasing the number of switch ports already installed. Understanding traffic patterns is very important to network switching, and the goal of being to eliminate or filter as much traffic as possible. A switch installed in a location where it forwards almost all the traffic it receives will help much less than one where it filters almost all the traffic. Networks that aren't congested can actually be negatively impacted by adding a switch. Packets processing delays, switch buffer limitations, and the retransmissions that can result sometimes slows performance compared with a hub-based alternative. So just because you've got a big IT budget doesn't mean you should go and get a stack switch for your network where you've got 10 people. If your network isn't congested, then don't replace hubs with switches. And how you can tell if the performance problems are the result of a network congestion, then you measure the utilization factors and the collision rates. Network response times, the user visible part of network performance, suffers as the load on the network increases. Under heavy loads, small increases in user traffic often result in significant decreases in performance. This is similar to a car freeway dynamic, in that increasing load results in increased throughput up to the point that you get traffic jams or a deterioration in throughput. In Ethernet, collisions increase as the network is loaded, and this causes retransmission and increases the load, which can cause even more collisions. The resulting network overload slows traffic considerably. So using network utilities found on most server operating systems can determine utilization and collision rates, and both peak and average statistics should be considered as well. So a switch. Adding a switch to a backbone. This is basically how you do redundancy. Congestion on a switch network can usually be relieved by adding more switch ports and increasing the speed of the ports. Segments experiencing congestion are identified by their utilization and collision rates, and the solution, if you really do have to increase, is to do something like this. So at the right top here you have your core router, and then after that you have your core switches, and then each of the core switches has a redundant link to each of the switches underneath here. And then underneath there you have your servers connected to each of the switches, which would make it pretty damn redundant. I would have done this slightly differently. If I was designing the network, I would have had kind of broken these up into banks of 2 or 3, and I would have had this server not only connecting to that one, but I would have had it connecting to this one as well, or maybe even that one, and this one connecting to that one, and that one. So if this one switch was to die and all these connections were to go off, then you wouldn't lose this server necessarily, because it could still have a redundant path to each of these other switches here. So this is how you do redundancy. You've got four core switches. You've got 1, 2, 3, 4, 5, 6, 7 lower tier switches, and each of those switches has a redundant connection back up to its core switch. There's going to be a massive amount of traffic over this network, but each of these links here would be a single collision domain. So hopefully the collisions will be kept to a minimum. And now if we actually have a look at an application made by Cisco called Cisco Packet Tracer, we can have a look, or we can create like a virtual lab and have a look at switches, and we can have a look at the interaction with them and see probably how they function.